All right, here we are, SAT 22 for week 4, 2025. And we have ourselves a student-produced response question. Looks quadratic. I see a parabola here. Let's take a look at the question. The graph of y equals 2x squared plus bx plus c is shown where b and c are constant. What is the value of b times c? All right, before we dive into the solution, let's see how we answered this, shall we? So this bar graph is kind of terrible because there's so many small little numbers we can't quite read what these percentages are. Not that it really matters, because you can see one clear spike right here with nearly 70%, 68.1% of us answering this. It's something in between negative 24, negative 26. I wonder what it is. And nothing even comes close. So the next highest answer over here was 8 respondents at nearly 5% at 24. I think there was just a little bit of a sign error, which might be a spoiler for what the actual solution is in a second. Okay. And then we rated this, well, you can clearly see. This is like right down the middle. We thought it was a fairly medium level question. All right, let's dive into the solution. And when we do, I'm going to do this both with and without technology. So if you do not know how to start this question, Desmos is absolutely your friend, as we're about to see. Okay, so we have our quadratic in standard form here. So it's usually like this, right? Ax squared plus bx plus c, but it does give us our a value. Our a value here, in fact, is a 2. And we just have to figure out what the b and the c are separately. And when we're all done, we have to make sure that we multiply those two things. Okay, so how are we going to do it? So, like I said, you could plug this straight into Desmos, which we will do here shortly. But this is actually really, like, if you know something about just functions and function evaluation, plugging points in, you can actually solve this fairly quickly. So the point that I'm going to focus on here is the y-intercept. So the y-intercept here is at 0, negative 6. So if I plug myself in a 0, that's going to zero out both of these x's, and then my y value is going to be equal to negative 6. This is really convenient because it's going to automatically give us one of those two parameters here. Can you see which one we're going to get? Here, let's take a look. So I'm going to plug negative 6 in for y is equal to 2 times 0 squared plus b times 0, and then plus c. And then we can see that these guys just go away because they're just zeros. And I have myself negative 6 is equal to c. And I'm halfway done. Boom. Okay. And so if you know something about the standard form of a quadratic, that's a parameter, that c value, that you could have gotten really fast because it is, in fact, the same thing as the y-intercept there. Negative 6, that's what it's going to be. Okay. Now let's look at the b value. So the b value I'm going to do very similarly. I'm just going to pick one of the other points that are on the parabola, and the one that I'm going to pick is my favorite. It's the vertex here. So the vertex here has the coordinates negative 1, negative 8. So I can do the exact same thing. I can plug negative 1 here in for my x's. They're not going to zero out this time, but it's negative 1. It's pretty easy to deal with. And then set y equal to negative 8, and then I can solve for my b value. All right, so this is fairly straightforward. I'll go ahead and plug stuff in. Negative 8 is equal to 2 times negative 1 squared plus b times negative 1. And then we already know what our c value is, and that was, what was negative 6? There we go. My b's and my 6's, they look kind of similar. Hopefully that's not terribly confusing. Now, back up here, it was really, really nice that we had this 0.0 comma negative 6 so that we were automatically able to get what the c value is. Sometimes that's not the case, and what you have to do is set up a system of equations, but this one you can absolutely avoid all of that. All right, anyway, so let's simplify here and solve this thing for b. Negative 8 is equal to negative 1 squared, just 1 times 2 is going to give me 2. And then now this is going to be a minus b because I'm multiplying b times negative 1. and then still minus 6. All right, so combining our like terms on the left-hand side, negative 8 is equal to negative 4 plus b minus b. Whoa. And then add the 4 over to the left-hand side. It's going to give us negative 4 is equal to negative b. And then just multiply by negative 1, and we can get b is equal to positive 4. And now you might think that we're absolutely done, but we're not, because we still have, this guy to do. Before I do that, though, let me show you something else that you could have done that I think is maybe even quicker than this one here. And that is the fact that the vertex goes through this axis of symmetry, if you remember that vocabulary from algebra, and the x value of that axis of symmetry is very easy to find. And I'm going to write down a formula that I know you're familiar with. It is the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this part of it, the negative b over 2a, is in fact the x-coordinate of the vertex point, and it's also the equation of the axis of symmetry. Essentially what this is that here is negative b over 2a is where this red dashed line is, and then if I add this extra part to it, I get my first x-intercept, and if I subtract it, I get my second one. And you'll see that a little bit in Algebra 2 next year for sure. Okay, so if I use this new equation here, that x is equal to negative b over 2a, again, let me make note that this is the x-coordinate of the vertex. And we already know what the x-coordinate of the vertex is. It was right here at negative 1. So if I set negative 1 equal to negative b, which is what I'm looking for, over 2 times my a value, and my a value back up here was 2, and you can see how quick this is going to be solved. So down here at the bottom, of course, I've got a 4. Multiply the 4 over, negative 4 is equal to negative b, and just like before, I just have to get rid of the negative, so b is equal to 4. All right, almost finished, of course. Now, one last thing to do is to multiply b times c. My b value was 4. My c value was negative 6 for a total of negative 24. So negative 24, of course, was the winner. And let's just say, for example, you're working on this question and you see this actually on your test and you have to clue what to do. Remember, it's, Desmos active the whole entire way. So you could just start plugging things in, and let's take a look at how we can solve this if we knew none of the algebra whatsoever, but we were adept at actually using Desmos. So I'm going to type in the quadratic exactly as it appears on the page, even with the b's and the c's. So it was y is equal to 2x squared, and then not minus b, plus b, and a bx, and then plus ac. Now the next thing I want to do is actually right down below where it says add sliders, we're going to choose all. So I'm going to get a slider for my b, and I'm going to get a slider for my c. And this C1, notice that what it's doing is that it's basically just moving my parabola just straight up and straight down. And let me snap this thing to like an integer or something. And you will see specifically that that number, in my case 1, it's the same thing as the y-intercept, which is what I was telling you when I was doing this whole thing by hand. Okay, now in order to make this a little bit easier for you to match things up, it makes sense to actually put the ordered pairs of the dots that they gave you in the original graph. So we could just type these guys in. So for example, we had the y-intercept at 0, comma, negative 6. That's going to put a dot there if you wanted to. You could label that thing. We also had our vertex. Our vertex point was at negative 1, comma, negative 8. Right? And maybe I put in that third point. So the third point is just it's basically the reflection of the x or the y-intercept across the axis of symmetry, and I believe that point is negative 2, comma, negative 6, right there. And now what I'm basically having to do is just move my sliders around until it just fits perfectly lining up with these dots, right? So it's just a bit of trial and error here, trying to move these things around in order to get your dots to line up. Now, I can make this a little bit easier if I change something about my sliders, because I have a feeling that this is probably going to be some integers. That is not necessarily the case, but it'll at least allow me to maybe snap these things into integers to just narrow down some possibilities. And if it's not an integer, I can go back and change it to something that's not an integer and, just finesse my little sliders here. So I'm going to click on a slider and choose my step size and just make it 1 on both of these guys. And now, whenever I move my sliders, you can see I'm just snapping into integers there. Ooh, that looks like it's pretty close. And then what? Let's see. That one definitely goes through one of my points, and maybe I just need, oh, there it goes. And take a look. You can see right here on the screen, my B value is equal to 4. My C value is equal to -6. It snapped exactly into those points for me. And, Desmos will even find the actual answer for you if you just type in B, C, just like that. And you can see right down there at the bottom, we have a -24. So I think that should conclude this video. Pretty easy question, straightforward, I would say, if you know what you're doing algebraically, and even if you don't, Desmos can help you out.